Hi, hello, ladies and gentlemen. This is teacher Walter, who's back again. We are still together always in mathematics, senior 6 now. And we are dealing with complex number, which is the first unit in senior 6. Ladies and gentlemen, so far we have seen a lot of lessons on complex numbers. And we have discussed a lot about complex numbers. We have done many operations on complex numbers. We have seen in different ways we express and know a complex number in different forms. Ladies and gentlemen, we are back now here to see in applications where we use complex numbers. So we use complex numbers in different ways, but I'm just to discuss with you the few ones, the very important ones, but we shall also see maybe in another opportunity the other importances. So the first one that we are going to discuss in this lesson is that we use complex numbers to find the trigonometric numbers over multiple over an angle. So, ladies and gentlemen, we have learned this maybe in senior 5 in the formulas of trigonometry, where we have seen how we can find the multiples of an angle, maybe the duplications angle and whatever duplication angles, double angle formulas and whatever. So, but here we shall see in general how we can see the multiples of an angle in trigonometric form. So now, ladies and gentlemen, what do we use? Here we shall mainly use two things. We shall use the binomial expression of Newton binomial expression, and we shall also use, ladies and gentlemen, what we have seen as Euler's formulas. We also go for Euler's formulas. We come for the second application where we shall be linearizing. But now here we shall mainly need what we have seen as the De Moivre's formulas. Remember the De Moivre formula. De Moivre formula. It was saying that the De Moivre formula was saying that if we have cos theta plus I sin theta, all of this power n. Some of you remember it. And this was equal to what? This was equal to cosine n theta plus I sin n theta, ladies and gentlemen. This is how was the De Moivre's formula. And it was when r equals to 1. That's why it remained like that. So we shall use this De Moivre's formula and the binomial expression where we now expand this. Cosine theta plus I sin theta power n. We expand it using the binomial theorem from Newton. So, ladies and gentlemen, we shall have an example of how we can do this, and then maybe you can understand better. So, a better example, ladies and gentlemen, is to express. I will ask you to express cosine 3x. Maybe because cosine 3x and sin 3x, express cosine 3x and sin 3x in terms of sin x and cos x. Just this. I will ask you to do this. How are we going to do this, ladies and gentlemen? We shall have an answer here. The first thing, ladies and gentlemen, you will see that here n equals to 3. The multiple, it is just x is the angle and its multiple is 3. We shall just multiply x by 3. It means that the angle x is the multiple of 3. So what are we going to do? So n here, n equals to 3, ladies and gentlemen. Now, using the De Moivre, using the De Moivre formula, ladies and gentlemen, if you use the De Moivre formula, what are we going to get? If you use De Moivre formula, we shall see that it is cos. Here we shall have now n is, remember we shall always start from here. It is cos theta, which is z actually, z which is equal to what now? Here, because we shall using De Moivre's formula, ladies and gentlemen, if we use the De Moivre's formula, here we shall have now cosine theta, but theta is known as 3 not 3x. So always we shall let x be what? We shall let z be always r cos theta, but theta is known. Now it will be cos x, but this r also, it's better to now not write it, but r is 1. We shall now just let it like this. Better we write cos theta, sorry, theta have just stabbed me a lot. I don't know why. So it is cos x plus I sine x. We shall let z be like this. It means r equals to 1. This means that r equals to 1. We don't write it. So now, if we have that, we shall find now z cubed. If we find z cubed, this will be cos x plus I sine x cubed. And now, ladies and gentlemen, using De Moivre's formula, if you use De Moivre's formula, we shall have now cos 3x plus I sine 3x, ladies and gentlemen. Now, using De Moivre's formula, and we have this expression, we shall call this expression star. We shall call it star. It is the first expression that we find using De Moivre's formula. And then our second expression will be the expression we shall get when n is again 3, but we expand this using the binomial theorem. So, ladies and gentlemen, you are used to know how we do with binomial theorem, and I will invite you to come with me so that you can see how we have used this binomial theorem. So, using De Moivre, from De Moivre we have seen that cos x plus I sine x power 3, this is cos 3x plus I sine 3x, ladies and gentlemen, and I have called this an expression style. Now, if I use now binomial expression, please follow me here, ladies and gentlemen. You remember one thing, a plus b cubed, this equals to what? If you remember very well this thing, a plus b cubed, this is a cubed plus 3a squared b plus 3a b squared plus 1 b power 3. This is what we have as binomial theorem. So if you use this formula of binomial theorem, which is from the expansion of Newton, and then we shall have what? We shall have now, we shall have cos x plus I sine x cubed. I invite everyone to follow it because this is kind of long, but we shall understand. So this is equal to what? It's cos x, which is like a. This is cos 3x plus, ladies and gentlemen, 3 cos squared x, then times what? Times I sine x plus 3 cos x, then I sine x squared, ladies and gentlemen, plus finally I cubed sine cubed x. This is what we shall find, ladies and gentlemen. Now, remember one thing, we have learned how to simplify the powers of I. So, ladies and gentlemen, this will remain cos cubed x plus. Now, this is, this I, we can come for the first there, and it will be 3I cos squared x sine x. And then, ladies and gentlemen, remember this will produce an I squared, which will be negative 1, which is now negative 3 cos x sine squared x. This negative is from I squared. Then, ladies and gentlemen, we have here I cubed. I cubed, remember, because it is I squared times I, this will be negative I. And we shall have now negative I sine cubed x. Very nice. Everyone can see this. Now, ladies and gentlemen, here we have a second expression. Without even going far, I can call this 2 star. If I call it 2 star, ladies and gentlemen, we have the first expression, which is here, gotten from De Moivre formula, and we have a second expression that we have got from the binomial expression, or the Newton law, which is really written here. We have it. So, ladies and gentlemen, if we compare these two expressions, so comparing star to 2 star. If we compare the two expressions, ladies and gentlemen, what do we have? We shall have now equality of two complex numbers. Ladies and gentlemen, remember that two complex numbers are equal when their real parts are equal and their imaginary parts are equal. We have seen this later. So, ladies and gentlemen, this is the real part of this complex number, and this is complex, it's the imaginary part. So the real part from the first expression should be equal to the real part of the second expression. So now we shall see the real part is cos 3x, which must be equal to the real part here, those without I. Ladies and gentlemen, how you can help me to find it? It is, of course, cos cube x, which is this expression. This one has an I, it's an imaginary part. This doesn't have, minus 3 cos x sine squared x. Is there any other thing? No. So, ladies and gentlemen, this is the real part of the first complex number star, and this is the real part of the second expression, which is 2 star. Now, ladies and gentlemen, we have also to compare the imaginary parts. The imaginary part is sine 3x, which is, of course, equal to what? Here we shall remove I, and we shall remain with 3 cos squared x sine x, then minus sine cubed x. And ladies and gentlemen, here we are done. Here we are done. The question was to express cosine 3x and sine 3x in terms of cos x and sine x. And this is really what we have done. So we have that cos 3x equals to this. And remember very well, these are things that we have seen when we were in senior 5, when we are looking at the formulas of the trigonometric double angle formulas and the other multiple of angles. So here now, we use the complex number to find the multiple of any angle. Maybe it can be 4x, can be 5x, can be 6x, it can be 2x and whatever, that it is a multiple of an angle. So we shall use these De Moivre's formula and the binomial expressions, and we express this. If they give you 2x, you will now find that n will be 2, and we find this squared. If they ask you 4x, it will be this power 4, and you use the De Moivre's formula and the binomial expression, and you get the thing. So, ladies and gentlemen, this is how we do it, and we are done from here. And now I will help you to now see whether you have understood this lesson through a small homework that everyone will try and see whether you have really understood. Ladies and gentlemen, I will leave you with a small homework. Yeah, ladies and gentlemen, we were on homework. I was telling you that I will ask you to express cosine 2x and sine x in terms of sine and cos x. And ladies and gentlemen, if you find that cos 2x equals to cos squared x minus sine squared x, you'll be very right, and you can just congratulate yourself. And now here you get to sine x and cos x. Ladies and gentlemen, this is how you will know whether you have really understood this lesson, and you can just maybe try more others like cos 4x, sin 4x, and whatever multiple of any angle you can have. Ladies and gentlemen, we are here ending this lesson, and I'm just inviting you to follow us on our website for more understanding, for notes, for explanation, for exercise and homework. We find this to our website www.ubumenyi.net. And ladies and gentlemen, if you also not satisfied, you can visit our YouTube channel, Ikaram TV, and you will find here a lot of videos that have passed, the previous ones and the coming one. Don't forget to subscribe for you to get all the coming videos on time. And I will just invite you to also share to your friends. I love you, and I also invite you for this next lesson, which will be on the linearization of trigonometric expressions. Thank you very much. I love you. It was Teacher Walter. Thank you.